Good Will Hunting was filmed in 1997 and was based around a mathematical genius from an unbecoming background. Will Hunting is born with a genius-level IQ, yet he chooses to work as a janitor at MIT, where he solves an unsolvable math problem for Professor Lambeau. Here he meets Sean Maguire, who helps guide him in therapy and show him what he truly wants in life. He seamlessly goes throughout the film solving math problems, getting job offers from all over the world at very high-up government agencies. In this video, I'll be going over all the problems that Will Hunting solved in the movie, and why some of these problems weren't actually as hard as they were made to seem. So, what does the professor actually ask his students to do? Well, he asks that they draw all homeomorphically irreducible trees of size n equals 10. So the first step in this problem is understanding what all of these words mean. A tree is just a combination of points and connections. You'll basically see them as a bunch of dots and lines. So this tree with the dots, each dot is a node. So this is an n equals 4. But there are some rules with these trees. So one of the rules is that we cannot create loops. So let me go ahead and draw a loop here for you. So this means that there's one whole loop going through, and that is not allowed. So next we'll go over what homeomorphically means. So what this means is that even though the trees have different angles, if they have the same number of connections off of each node, which is the dots, then they're effectively the same tree. We'll do a quick example of a node of size 6. Even though these angles are a little bit different, and they look different, if you look close enough, these are basically the same trees, just moved a little bit. So they're just rotated on the angles. So the last part, the irreducible part, basically means that we cannot reduce any of the nodes from the tree. I'll show you an example of a reducible tree and you'll see the difference. This one is reducible because we have that point in the middle, and if we were coming down on the node, we only have one option here, which is to continue straight, making that node here useless. However, this other node on the other one is okay, because whenever you go through that, you have the option of the endpoint. So what's actually interesting is that the creators of the movie made a mistake in the solution. The number of trees in the solution is actually 10. So how do we actually solve and find all of the 10 trees? So the first step that we have to do is that we have to ask what is the longest chain of nodes that we can make. And the answer to that is 6. So we make our 6 nodes and we'll start to draw them. Now, our method for figuring this out is we're going to have to end up actually counting the end nodes. So this one has 1, 2, and 2. Now we'll draw a second one here. This one is actually an n equals 4 node. So for this one here, we actually have a 2, another 2, and then a 1 branching off from that, not including that endpoint, because the endpoints actually don't count whenever they're branches off of the center chain. So this second one is also a 2, 2, 1 chain. So these two are actually both equal, even though they look very different. So since these trees are equal, they don't actually count. So in order to think through this problem, we're going to have to actually count our nodes that are on the end of the chain in order to make sure that we don't double up on different things. So now we'll start with drawing out the entire problem. I'd recommend doing this on your own and trying it out, but first we'll start off with our 6 chain, and that's our longest one that we can have. And off of this branching, we each have a 1 off of each one. This is going to be the least amount of values that we have. So now I'll go through and I'll do the rest of these, and I'll speed it up and you'll be able to see all of the answers and see how easy it is just to do this problem. So here's where our numbering option kind of falls apart, and this is our kind of one exception to the problem. We have another 5-node one, but we have one on each side on the left, and then we have 2 branching off of a single one on the right. Now this one we kind of just do a 1, 1, and then a 1 plus 2. And this here is just kind of our one exception to their problem. Now you may ask, who was the real Good Will Hunting? And this is kind of interesting in a way. So some say it was George Danzig, who was a kid who walked into his lecture hall late and thought that the problems written on the board were homework, when they were really unsolved theories. These 2 problems actually ended up taking up his entire PhD thesis. The other one could have been William Sidis, who was a child prodigy, who was known as the smartest man/boy to ever live, as he taught lectures at prestigious universities at only the age of 12. He supposedly had a higher IQ than Einstein's, and even with all this, he disappeared to live with what he thought to be a perfect life, which was a life in seclusion. Now, following along with that, there was another one that some said could have been in this movie, which would have been Srinivasa Ramanujan, which was an Indian man who learned all the math he could from a single calculus textbook, and with no teaching, came from a humble beginning and thought up many different number theories and series without any professional schooling. This movie showed mathematicians and geniuses as more than just a head full of numbers writing on any piece of glass they can find with an expo marker. They showed them not just as humans who find joy in what they do and understand, but also as people who love and have emotions. I'd highly recommend watching Good Will Hunting and solving this problem on your own, because all in all, it truly isn't that complicated.